Okay. Let's look at if we had, well, actually, let's go back to f of x is equal to 2 raised to the x. And I just want to sketch this graph out real quick, which it looks something like that. Now, what if, how do we get this graph to reflect about the x-axis? Well, for example, you would take 2, let's say, and you would plug it in to here, and you'd get 2 squared is 4, right? But down here, if you were to plug it into this function, you would get negative 4. All right. So all we have to do, and I'm going to call this one g of x, is throw a negative out in the front. So we would just throw a negative out in the front of this function here, and that would cause the graph to become reflected about the x-axis. All right. So what happens if our graph did this and we wanted it to do this? Right, be reflected about the x-axis. Well, we'll say that f of x is equal to a half, or I'm sorry, a half x. Should be an x there. Okay. To get this to reflect about the x-axis, we'll call this one g of x. You would throw a negative out in front. So you see, throwing a negative out in the front causes the graph to reflect back the x-axis here. All right. Let's actually look at some computer-generated graphs. All right, this particular graph here is a half raised to the x, so it's decreasing. As x increases, it decreases. Now, to get this to reflect about the x-axis, we would throw a negative out in the front of it, right? And as you can see, this is just a reflection, okay, about the x-axis here. Reflection about the x-axis. Easy enough. All right. Okay, I want to revisit an earlier topic, and that was inverse functions. And the reason why we even talked about inverse functions. So this is, we'll say this is 2 to the x right here. All right. And we can graph what the inverse is going to look like. Now remember, this line right here, this is y is equal to x, and I'm doing a terrible job of that, but this dotted line is y to the x. Now remember, and I'm going to do this in a different color, the inverse function, so this would be f inverse. And we don't know what this is, but we know that it looks something like this. Well, actually, this is not a dotted line, and I don't think I'm doing a very good job here of this. But remember that it's a reflection about this y is equal to x right here. Okay, the inverse function is a reflection about the y is equal to x. So at least we have an idea of what this inverse looks like. All right. So I just wanted to throw that in, that little extra in on us, since we covered inverse functions in the previous section, or just kind of a summary of what an inverse function is. I'm going to, let's see, actually, you know what, let's look at this part of it, the equations here, and go back to exponential functions. Alright, I want to talk about real quick here about exponential equations. Okay, and for example, if I had 8 is equal to 2 to the x, and we wanted to solve for x in this problem, well, I want you to think about this. What number could we possibly plug in for x that would give us 8? Well, what about 3, right? Because 2 to the third is 2 times 2 times 2, which is 8. So x is equal